Hello all, welcome to the YouTube channel of Hasmukh Goswami College of Engineering. I am Jaideep Jadia, Assistant Professor in Civil Engineering Department. In this course, Mechanics of Solid for BE second year third semester, I am going to cover the module about types of support and types of load on beam. So let's learn something. So first, for civil, mechanical and aerospace engineering, it is like bread and butter. So this course is very fundamental and conceptual. The objective of the subject is to equip the students with the tools necessary to solve mechanics problem, to know the material behavior under the application of load. So the outcome of the course is to study the equilibrium of force system, to learn the drawing of bending moment and shear force diagram, and to know the stress strain and its relationship with respect to failure theories. So what is mechanics? It is the science of force and motion of any solid material you are considering in the universe. To understand that physics, you need to know the mechanics. So what is applied mechanics? The science of applying the principle of mechanics to the system of practical interest to first understand their behavior and to develop the rational rules for their design. So the principle of mechanics are two. First one is force, second one is motion. These two things contains in which one is your cause and another one is your effect. Now the main topic of the session is different types of support. So first one is fixed support, second one pin support or hinge support, third one roller support, fourth one simple support. So first, fixed support is also called as rigid support, and the main characteristic is it restrains against both rotation and translation. It resists any type of force and moment. So it is provided for good stability to the structure. So this is the image of fixed support in which beam is fixed in wall. Like I said, fixed support restrain vertical movement, horizontal movement as well as rotation. So now the graphical presentation of fixed support. This is the graphical presentation of fixed support, and in this we can see the free body diagram which indicates vertical movement, horizontal movement and rotation, which is completely restrained in fixed support. Second one, pin support or hinge support. So this support can resist both vertical and horizontal forces but cannot resist moment. So it restrains against translation. So the good example of hinge support is door lift, which only rotate about its vertical axis without any horizontal or vertical movement. So image of hinge support at Sydney Harbour Bridge. So it is the hinge support or pin support. So now graphical presentation of hinge support. Here we can see it restrain vertical movement as well as horizontal movement, but it will allow rotation about the support. Third one, roller support, is only resist vertical forces, cannot resist horizontal forces as well as moment, provided at one end of bridge span, because as we know, due to temperature change concrete may contract or expand. So it will restrain the movement of another bridge deck and reduces the stresses generation in bridge decks. So the image of roller support on the end of bridge, here we can see roller support. graphical presentation of roller support, and in which we can see it will only restrain vertical movement. It will allow horizontal movement as well as rotation about a support. Fourth one, simple support. Just a support on which structural member rests. So it cannot resist lateral movement as well as moment. So only resist vertical movement of support with the help of gravity. So in case of frequent seismic activity, simple support structure can be seen. So let's see the image. So here we can see beam is resting on column without any connection. So it is called as simple support. Now graphical presentation. Here we can see beam is resting on support without any connection. So now in short comparison of different support. Here we can see hinge support, roller support and fixed support, which is generally designed in structure. So we know hinge support restrains horizontal movement, vertical movement, but allows rotation about a joint. Second one, roller support. We can know it restrain vertical movement only, but cannot restrain horizontal movement as well as rotation. In third case, which is fixed support, it restrains horizontal movement, vertical movement and rotation about a joint. Now the second point of the session is types of load acting on beam. So first one is point load or concentrated load, second one uniformly distributed load, and third one uniformly varying load. So point load or concentrated load, as names suggest, act at a point on a beam or distributed over a very small length. So let's see the graphical presentation of point load. So let's assume a beam AB of length L, which is loaded with point load W at the midspan of beam. So load W will be considered as joint load. Second one, uniformly distributed load, as the load which will be distributed over the length of beam in such a way that rate of loading will be uniform throughout the distributed length of beam. So let's consider the following figure. A beam AB of length L is loaded with uniformly distributed load and rate of loading is W. So uniformly distributed load is also synonyms as UDL in short, and its unit is in Newton per meter. So UDL means it is distributed over a certain length of beam with constant intensity. Now third one, uniformly varying load. So uniformly varying load is load which will be distributed over the length of beam in such a way that the rate of loading will not be uniform but also vary from point to point throughout the distributed length of beam. So uniformly varying load is also termed as triangular load. Let us see the following figure. A beam AB of length L is loaded with uniformly varying load. So it means the intensity of load is changing from starting to the end of load apply condition. These are the references I have used for preparation of this PPT. Thank you. And if you like this concept, please like, share and subscribe.